In this video, we are going to discuss about the velocity time graph, the graph that we use to illustrate the motion of an object, where we plot the velocity against time. Velocity measured in meters per second, time measured in seconds. So when we draw the graphs, initially we must know about the common motions and the related graphs. So what are the common motions? There are four types actually. When the object is at rest, resting velocity, which you term as zero velocity. For that, we do have a graph. And then uniform velocity, when the object is moving at the same velocity. And the third one, uniform acceleration, when the object is moving at increasing velocity. Velocity is increased. Uniform deceleration, object moves at decreasing the velocity. So these are the four types of graphs. For all four types of graphs, you do have their unique graphs. What are the graphs here? Here the graph I'm going to draw. For the resting velocity, when the object is at rest, When the object is at rest, the graph would be a blank graph where until the time, for example, let's say 0 timing we start and until 5 seconds I'm staying at rest. So until the 5th second from 0, I have to show it as a blank graph. I have to just mark a line over the x-axis. So that's velocity 0. Velocity 0. And the second one is uniform velocity, where the object moves at the same velocity. Somewhere here we have to take a parallel line. Somewhere it refers for what is the velocity given. That velocity you have to take. Example, let's say 20 meters per second for 10 seconds. 20 meters per second exactly from the y-axis you have to mark and parallel to the x-axis until the 20 seconds. Let's say 0 to 20 seconds. 0 to 20 seconds you have to mark. And the third graph is uniform acceleration. Object moves at increasing velocity, accelerating. Uniform acceleration graphs will be given in this way. The rate of change of velocity is uniform. So it is a uniformly increasing velocity. And the same way, when we want to draw uniform deceleration, it is decelerating, then the graph should be a negative gradient. This is a positive gradient and a negative gradient. So these are the four common graphs that we should know, we must remember whenever we are up to draw the motion graphs for velocity. So velocity time graph. So all the questions would be coming up combining any of them. Mostly these three are combined. Starting at rest, uniformly accelerating. This is the first graph. Second, it moves at the same velocity. This is the second graph. And third, it releases down. It reduces the velocity. So reduces the velocity up to 0. So uniform deceleration. So these three graphs are what mostly combined together. Accordingly, we can find out the answers. All right. So let's take an example. I'm going to take an example in this way. I want to show the motion of an object. This is the graph. So I say it's starting from 0. It is starting from 0. So starting from 0 in the first case, starting from 0, it acquires a velocity of 24 ms minus 1. And the time taken is 6 seconds. This is the first motion. Second motion, I'm saying it's moving at the same velocity it obtained for another 4 seconds. Another 4 seconds. And then the third motion, I'm saying it comes back to rest. Okay. Back to rest from the same velocity within 6 seconds. Within 6 seconds. All right. We have to plot this on a graph. How to plot the graph? Now, there are two methods of plotting, sketching the graph. One is we have to mark each and every point. That's one. That means 1, 2, 3, 4, 5, 6 from 0. We have to mark the time. And then here 1, 2, 3, 4, like that's one. Or else 2, 4, 6, 8 according to the measures. That's one method. Second method is we don't mark any of them, straight away only the data. And this is the most, recommended method, and it is what would be given in the questions as well. Right? That's not problem. We can use that as well. So how do we mark it now? According to the second method, this is 0. Starting velocity is 0, ending 24, and is acceleration. So very clear, increasing the velocity. So acceleration graph along these. This is the acceleration graph. Now I said you need the graphs. So I'm drawing the acceleration graph first. We don't have any other data, straightly acceleration. What I do, I'm going to mark it. 0 to how many seconds? 6 seconds. And this should definitely be the velocity which it has obtained, which is 24. And then what happens? It's moving at the same velocity. It's moving at the same velocity for another 4 seconds. So another 4 seconds means somewhere it should be less than this. And it should be the uniform velocity. And this is the uniform velocity. So from here, I can't go above straightly. So I'm taking apart a portion less than this. Okay. And I'll mark it here. Now another 4 seconds means 6 plus 4, it's 10. And then back to rest within 6 seconds. Decelerating back to rest, decelerating from the same velocity it has obtained from 24 ms minus 1, and another 6 seconds, somewhere the same like I have taken, and deceleration graph goes like this. From here, I'll take it down. So 10 plus 6, it is 16. I have to end up at this point. So these are the points that I have to mark, and this is my VT graph for the motion. So you see, to draw the motion, to represent the motion on this graph, I should know all these 4 graphs. And if I can remember them, easy I can mark them, easy I can plot them. So accordingly, let me show you the graphs once again. So these are the 4 graphs that you should know. Velocity time graph, we can observe here. V equals 0, and the second graph goes up with velocity, same velocity. Third graph goes up with acceleration, increasing velocity. Fourth graph goes up with decreasing velocity. So accordingly, these graphs, if you can remember, you can easier get into the points, right? You can easier draw the diagrams as well. So once again, we can observe the graphs here. Uniform velocity is the second one. Third one, uniform acceleration. Fourth one, uniform deceleration minus a, and velocity 0 means it should be a blank graph.